Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of solving rate problems. This is standard 7.4D in the great state of Texas, and we are using item number 9 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So they're going to give us a ratio here of boys to girls of 2 to 3. So let's go ahead and label that. So 2 boys, 3 girls. And then we've got 18 girls in the class. So what is the total number of students in Miss Cunningham's class? So notice the question. Total number of students, we would expect that to be boys. We're going to need to figure out the boys. But it's not boys, it's students. So just watch out for that little trick right there. So let's first start with this ratio. Let's figure out how many boys there are, right? So we've got this ratio of 2 boys to 3 girls. And then it says there are a total of 18 girls in the class. So what we're setting up is a very basic proportion. Our girls are going to be our denominator. And so I'm looking for boys right here. I'm just going to make that X right there because I'm going to need that for my total number of students. So let's just do a little cross multiplication here because we know that those are equal. And so it looks like I've got 3x equals 2 times 18. So let's just say 2 times 18, that is 36. So let's divide both sides by 3 to isolate the x. And so it looks like my x is going to equal 12, which is one of my options. We're not going to choose that. That's the number of boys, not the number of students. Before we find our number of students, let's see if there's another way we could have figured out how many boys there were. Because when we're looking at rate problems, most of us are thinking of this right here. Y equals kx. So our x is our independent variable. This gets things going for us. And then we multiply it by k. Right? This is going to be our constant of proportionality. So there is some type of constant that regulates the ratio here. And then we're going to end up with y, which is our dependent variable, because what y is depends on how we start with x and how we multiply it by k. And so we are going to be able to still do that. It's a little bit weird to think of that, but watch, we can do this right here. We can say boys to girls. So let's just start with that as our x, right? So let's just say our boys is 2. I'm going to say 2k. And so I'm going to flip these right here using the commutative property. Just flipping the order, and our girls is 3. So if I wanted to figure out what that constant is, I just divide both sides by x here, right? And that's why we know k equals y over x. So really it looks like 3/2. So k equals 3/2, or we can call that 1.5. So what I can do is I can use that in my new equation here because there are 18 girls. Remember, my girls was my y, so I can say y equals kx. And then you can say, well, if there's 18 girls, that means I multiplied my k, 1.5, times my x, which is the number of boys I need. How do I get that x on itself? Well, we just divide both sides by 1.5. So what I need to do here is I need to do a little bit of long division. 18 divided by 1.5, but you'll get the same thing. You're going to get 12. So we got 12 boys. We got 18 girls. We add those up and we are going to get 30 total students. Our answer here is B.